Hello, my name is Vijgen. As an artist, I'm interested in making the invisible visible. We are permanently surrounded with thousands of signals from wireless devices. The air around us is literally filled with information. What if we could see those signals? How does the information on our screens move through space? In my work, I explore the spatial qualities of wireless communication. It's easy to think of Wi-Fi as an invisible line between a router and a device, but reality is much more interesting, much more strange. Most of our devices use electromagnetic waves, also known as radio waves, to communicate with each other. While radio is more than 100 years old, it is at the core of most modern-day technologies. Today, the electromagnetic spectrum is divided into hundreds of slices, each dedicated to specific applications like FM radio, GPS navigation, or mobile phones. One of the bands of a 5G mobile phone is the 800 MHz band. When a cell phone broadcasts waves at a frequency of 800 times a second, it creates a cloud of electromagnetic waves around it. What does this cloud look like? How do objects, buildings, and cities change the shape and scale of this cloud? In my work, I've been using different techniques to visualize these invisible dimensions of the world around us. I've used existing datasets, antennas, or digital receivers. Each of these techniques had allowed me to capture and visualize a certain aspect of the electromagnetic space. But each technique also has its limitations. When I heard about the Start-Air program, I realized that there was a third option that I hadn't explored: simulation. Electromagnetic simulation software allows you to calculate the behavior of electromagnetic waves in space and visualize the resulting shapes in 3D. I had heard about this technique before, but as it requires computing resources that are way beyond the scope of a normal computer, I put it aside. The Start-Air program offered a unique opportunity to put this idea into practice. The Barcelona Supercomputing Center not only provides enormous amounts of computing power, they also have great expertise in wave simulation and data visualization. Together with Altair Engineering, a leading publisher of industrial wave simulation software, we were finally able to explore the behavior and aesthetics of electromagnetic waves in urban space. Using existing 3D city maps of Barcelona and Rotterdam, we started to simulate the behavior of different wavelengths and compare the results. We were able to visualize how different city topologies lead to different electromagnetic patterns and reveal a hidden technological dimension of reality. After assessing the first results, we decided to explore movement. How does a person moving in space affect the shape of the electromagnetic patterns? Finally, we decided to do a simulation of a signal at a fixed point in space where the frequency would gradually increase from 1 Hz to 1 GHz. With this, we aim to develop a simple interactive tool where a user can set the frequency with a slider and see how the frequency determines the shape of the electromagnetic patterns. The expertise at BSC and Altair allowed us to proceed at a steady pace. Still, the scale and wavelength of the simulations proved uncharted territory for all involved. A lot of trial and error allowed us to find the right solvers, identify performance bottlenecks, and finally bring down the runtime for a single animation frame from more than 15 hours to a little over 2, making animated series feasible. The results reveal an invisible dimension of reality, a hybrid of architecture and information, and a new way of seeing the modern city. While there may be practical applications in the field of optimizing wireless connections, or maybe designing buildings to reflect or absorb signals, actively create online and offline spaces, the biggest impact may be in a more intuitive understanding of data and space. Instead of fearing what we don't understand, we might appreciate the beauty of information and explore these strange new landscapes.